Muchas gracias. Hola, señores y señoritas. Buenos dias. That's about all I know. So thank you so much for having me. Thank you to the government of Argentina, the Chamber of Biotech. It's been an amazing time that I've had so far here in Buenos Aires and now in Mendoza. You have an amazing country, beautiful land, and incredibly warm and gracious people. And that's one of the reasons I came. I think I'll get into this in a little bit, but just I want to say up front, I'm an investor. I invest in biotech companies. And out of all the companies I've invested in, Argentinian founders tend to be at the top. And I didn't know why. It's a strange thing. I'm in San Francisco. I invest in companies from all over the world. But for some reason, this pattern started to emerge. And after 4 years, I say, OK, I need to go learn a little bit more. So this trip is a bit of a discovery mission for me as well. So thank you for having me. I'm here today to talk to you a little bit about IndieBio and how we do innovation at the very beginning. How, as the speakers Hugo before me said, lowering the cost of risk. Risk is expensive, and it keeps people from doing innovation. So if you could lower the cost of risk, you could actually do a lot more innovation. And that's what I want to talk to you about. So there we go. A little bit about me. I have a background that spans both genetic engineering, which is what I was educated in, and then I went on to do a master's in industrial design, where I went and designed things like the Samsung Galaxy Curve. That's what it looked like before it came out. And I worked on this ciliate called Tetrahymena. From there, I was asked by venture capitalists to think about investing. And I thought about what would be the real problems to work on in the world. And from my time in designing consumer electronics and things like that, I realized it didn't matter. That doesn't matter. What matters is climate change, human health, how we could actually change the world for the better. And I realized that biotechnology had arrived today. 20 years ago, it was too slow still, genetic engineering. But today it's gotten faster and cheaper. And this is what I was worried about. This $100 trillion opportunity. That's the actual right number, $100 trillion. And that $100 trillion is the amount of the global GDP today. And the global GDP has doubled every 25 years for the past 100 years. In the next 25 years, the global economy will add another $100 trillion. Or something very bad is going to happen. And that population growth curve is potentially the tipping point for that bad thing to happen. Because we can no longer provide all the things that this growing wealth from all the nations around the world, we can't provide those goods and services without destroying the natural economy, the natural environment of the planet today. So there's both a looming crisis, but in that looming crisis, a $100 trillion opportunity. So how do we tackle that? How do we go and grab that and save our future from scarcity and unrest, which happens with inequality, which comes from scarcity? That's the future that we're trying to avoid. There's already shortages, as you heard, water shortages, other natural resource shortages. We have to solve for that. It will just continue. This is the Arab food riots from 2017. And so biology as a technology can create surplus because it has you have one ability that no other technology has, which is to reprogram life from scratch to be more efficient. That alone can change everything. And so we can try to create things that sound like science fiction before, and today save our planet from being over-consumed. For humans, for people, it also helps us live longer and live better. That's a big issue right now as well. Cardiovascular disease, diabetes, so many different diseases are coming up, cancer, that have real issues, that real problems, and creating massive drains on our economies. In the United States, the healthcare system is so broken that it accounts for 1/3 of the entire economic burden. So how do we, in this room, start to tackle such enormous problems? It feels hopeless for a lot of people, but it's not. It's definitely not hopeless. And you start with first principles, science. Everyone in this room is an expert in this process, the scientific method. We learn this in grade school. How do we investigate the world? Well, we make an observation, we ask some questions about it, we collect some data, does it match what we thought, and then we ask more questions. Pretty simple. Design is the same exact process. And I know this because I'm trained in both areas. And I've taught design to CEOs of Fortune 50 companies for 10 years. And this is the simplest way I can explain it. Basically, you go out and talk to people about their problems, and then you go and make some product to solve that problem, and then you kind of iterate that until it's ready for market. It's exactly the scientific method. And so I realized that these are actually the same toolboxes. They just have different problems that they're trying to solve. In science, you're trying to solve for scientific discovery over the career arc of a scientist, 30 years. In design, you're trying to do this for a product cycle, a week to a year, very quick. And so, really, because they're the same thing, I realized that scientists could actually be entrepreneurial because they have the DNA already in them, pardon the pun. So these scientists, instead of going and asking very simple questions about nature, they just start to solve problems for people that have products at the end. And they could use the exact same process that they have. And so there is a real opportunity happening right now. I was speaking about this the other day to Miguel from CONICET about this exact opportunity. More people are graduating with PhDs around the world than ever. Most importantly, these PhDs don't have jobs to go into. As a PhD, the ultimate job is being a professor. Go and continue your work of inquiry. Those professorships are less and less every year. But the silver lining there is biotechnology is getting cheaper and cheaper to do every single day. So these enormously talented people that are extremely creative, that have created new knowledge in the world to get the PhD, a new paper, peer-reviewed, can take that drive and go build a company from scratch. And that is happening daily. So as we know, biology is accelerating faster than Moore's Law. This is the cost of DNA sequencing, and it's falling rapidly. If you look at DNA synthesis, it's also following a similar pattern. And new tools allowing you to look at biology more like product design is happening every day. So what I call read, write, copy, and paste, right? So we can sequence, we can synthesize, we could actually use AI and machine learning, computational platforms. And finally, CRISPR is allowing you, in the research context at least, to make edits very fast and efficiently. But building a company today in biotech requires you to reject all sorts of conventional wisdom. 5 years ago, if I told you, I'm going to start a biotech company, you would say, great, you need at least $10 million. It's actually not true anymore. Nowadays, you just need a few $100,000 and access to a lab. So scientists, obviously, now that we've gone through the backgrounds, can be entrepreneurs, 5 years ago, no one would tell you that's true. No, 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 no. You need business people to come in and run this company. And finally, biology was definitely only for therapeutics. If you started a biology company, oh, you're trying to cure a disease. Again, biology is a technology that can be applied to all sorts of problems because, again, you could reprogram life to become more efficient. So that's the theory of everything that went into building IndieBio and building this new way of making companies. How did it actually work in practice? So far, IndieBio has funded 115 companies in about 4.5 years. 4 of them from Argentina itself. And in that time, over $250 million of capital have flown into IndieBio companies. IndieBio has invested about $30 million itself. Over 600 jobs have been created. Over 70% of our companies raised $2.1 million or more on average. And finally, currently, the net enterprise value of our portfolio of that 150 companies is $1.6 billion. And with these funding rounds that are happening right now, when they close, that'll go to $2.2 billion within the end of the next month. So the experiment, as I call IndieBio, is starting to work. And so here's 3 lessons that I wanted to share with you from the labs of IndieBio that you could maybe implement in Argentina. 1, this is going to be generally a shocker for most scientists. The solution is far less important than a good problem. So what do I mean by that? If you start with a really, really good problem, you're going to find a solution eventually that unlocks a large market. If you have a solution you think is really good, there's a really good chance it's not going to work. And if you don't have a good problem that you've identified underneath it, you're done. That's the end of your company. So having the right problem matters more than the solution you created in university. Number 2, great teams are obsessive about their customers. Seems obvious, everyone says it. But in science, most people don't think about that. In science, the science either works or it doesn't. Well, the science can work, but no one could also care. So you need to make sure that your customers care about the solution you're creating. A good example of that is XSTEM. They are a company we funded that went out. They were making stem cells, mesenchymal stem cells, very cheap. They could make it for $30 an aliquot. It's normally like $3,000. And so when they went out to go sell it, they found out people didn't care about the price. Oh, yeah, I don't care if it's cheaper. And they were like, oh, no, what do we do? Because they continued to understand their customer, they found out that, it's not just that the price that mattered to the scientists. What mattered to the scientists was actually the variety of the donor of the stem cells. So because they had a cheaper way of making that stem cell to begin with, they were able to create a much larger bank, which then spoke to the customer. If they weren't speaking to the customers all the time about that, they would have never been able to figure out the right product market fit. So again, going back out, and even when you hear a no, not saying, okay, well, maybe we should make it cheaper until they say yes, going, okay, well, what is it that there's actual pain around, and how can we use our solution to address that? And then the third, building prototypes is critically important. Because I like to say this all the time. Nobody is an expert in the unknown. Nobody. You can have Nobel Prize winners and show them something that's unknown. They're not an expert in it. And it allows an open and humble mind to do very well in that situation. Because the way you discover the unknown is by exploring and trying things, not by sitting at Google. And so when you build prototypes, you're actually discovering the unknowns that exist, but are going to eventually derail your business. A good example of that is this company called Astrona, which they were making a test for microbial contamination for foods on production lines. And so they had a very sensitive RNA-based test, and it was very good. And they were in the lab all the time, making it more and more sensitive. And I was always screaming, please get out into the line and try it. And they finally said, OK, Arvind, I'm tired of you screaming at us. We'll go out on the line. And so they went out on the line, and they discovered the biggest issue they had. The sponge that they were using to collect the sample wouldn't let go of the bacterium it was picking up. So they just had a mechanical problem. They literally, their test with all the science behind it that made the actual assay work failed because of a silly sponge problem. And so they went on this huge sponge deep dive and found the one that worked. They would have never, ever been able to solve that problem if they had found out at the last second. And so the key is to discover your unknowns as early as possible, because you want to know what's going to kill you when it's still cheap and not when it's extremely expensive. And so based on all of this, where are we going? What does the next 5, 10 years hold? At IndieBio, we have a unique view into the world because we see through the halls of academia all over the world. And I see all the projects that are happening and where it's all shaping up to. So I'll share a few areas with you where I think and I see innovation going. One is regenerative medicine. So regenerative medicine had a failed attempt about 20 years ago when stem cells first came out and were discovered, and everyone thought, oh, okay, we could use stem cells for everything. Turned out not to be true. But it's enjoying a resurgence right now because we're understanding a little bit more about what makes stem cells tick. The most interesting application of that is one company we funded called Prellis that's actually using lasers to 3D print human organs. And the idea would be that you could walk in, if you need a new kidney, a new liver, a new heart, donate some of your stem cells, and then have that 3D printed over the next month, and then that organ transplanted back into you using your own cells. Alongside this, we're looking at regenerative medicine stem cell therapies for Parkinson's and other indications. One of the biggest areas we've seen at IndieBio in terms of profitability is carbon reduction. I think this is just the beginning. I've been saying this in cocktail parties and at coffee before. The best asymmetric bet, I think, in all of investing right now is carbon-based companies. What do I mean by that? So Memphis Meats makes meat without the cows. And I know that's a big deal in Argentina. They make, why do people care about that? It's the same meat. It's got the same health profile. They care about it because it reduces carbon footprint. Kids are angry right now. I was just saying this. 14-year-olds, 15-year-olds, 10, 12, they are all very angry. Greta Thunberg has given a voice to that anger. And they're changing their parents' behavior. Parents are now paying more money for sustainable products. This is going through the entire supply chain. I was speaking to the CEO of Carbon Recycling International, which makes green methanol. And he called it a green tsunami going through the supply chain. This blew me away. B2B never pays a premium. Everyone's starting to pay a premium for carbon reduction. And this will enable these young, angry people to vote, to actually be able to make a change in the world through their dollars. That's the only way they can. And so the reason I love carbon reduction as an investment class also is because it's a great regulatory bet. Right now, it might be inferior to conventional fossil fuels because of regulation. But when the kids are angry and they start voting, regulatory can flip that very quickly, and these companies become extremely valuable. The ones that are positioned to deliver will become very valuable very fast. Along those lines, biomaterials. So the food supply chain is being reinvented currently. And that's all in the news every single day. Biomaterials will reinvent the rest of production very soon. And wood, this is a company we did called Lindgrove. It makes wood without the trees. That's an actual photo of their chair. So the material is as strong as steel. It's made of flax, which grows in 6 days. And you don't have to cut down entire rainforests to provide nice chairs. Cell-based plants will complete the food revolution. So that's not a typo, cell-based plants. It's the other side of cell-based meats. So while people coming out of poverty demand animal protein, the cell-based plants will be able to deliver therapeutic, functional aspects of plants in a much, much more efficient way. What do I mean by that? Aloe vera has to grow over months and months, years to get to a certain size where you could then harvest it and then purify it and take out the carcinogen, which, if you didn't know, aloe vera has a carcinogen involved inside of it, and it's expensive to extract. Now you could take just the cells that are involved in production of aloe, the active ingredient of aloe, and produce those in a bioreactor. It's much more efficient. You don't have to grow the roots, you don't have to grow the leaves, you don't have to grow any of those things. Feed it sugar and create the actual active ingredient you want. Taxol is made from one entire yew tree. You don't need to create that tree to create the therapeutic for it, for cancer. And then finally, novel bioreactors are completely changing the way we think about rematerializing the world. I brought this up for Argentina specifically as well because you have a very strong production sector here, bioproduction sector. And so novel bioreactors, this is a hollow fiber, single-use bioreactor. Some of you guys may recognize this. We just funded a company called MemBio that's making whole blood, type O negative blood, using this type of a bioreactor to eliminate transfusions. And so it's blood donations for transfusions. So again, thinking about what type of chassis, workhorse, what kind of cell are you using for production, and what kind of bioreactor are you using to grow it up is extremely important. We funded a company from Argentina called STAM that is a fundamental bet in this space. They're developing a completely new bioreactor that will change yields if they get it to scale. And so the last section, I'd like to talk to you a little bit more about Argentina and Latin America. Again, I'm agnostic to the world. I'm here because I'm following the data. And Argentina is truly leading this Latin American explosion in biotech companies. And like I said, I don't know what is driving it, but I'm learning more and more about it. And one of the things that I'm seeing right away is this model that GridX is using, I think, is a model for the world to follow, including the United States. This model doesn't exist in the United States. So what you see here is a slide from GridX that I stole. And it's basically showing how they go around at the lab level and start to organize the projects around themes and application, and then go find entrepreneurs and business people that they could come together, and they create these teams around a potential future opportunity. It's one of the things that is being done here that isn't being done in other countries, and I believe that's the correlation, that we're seeing outliers in terms of the companies we're funding out of Argentina. And I think this is an inspiring model for the rest of the world, and something I'm thinking about trying to help others in the United States figure out. And so again, I'm following the data. Just to share a little data with you. We funded 7 companies total from Latin America. And those 7 companies have raised $39.6 million from Silicon Valley venture capitalists, from top-end Silicon Valley venture capitalists. And in, 2 years, they've created $147 million of value. That's a very big deal. It's hard to describe how explosive that is in Silicon Valley even, in the Silicon Valley biotech scene. So just from Argentina, we have Casper. We have, in our current class, Microma. Microma is making food dyes from fungus that is not an actual chemical. We have STAM, I mentioned earlier, and BFlow, and everyone seems to know Matthias Viel. So I'm extremely excited to continue funding Argentinian companies. I think there is something special about the entrepreneurs here, and I've been asking everyone, what do you think it is? And people tell me the same thing over and over again. It's because it's hard here. If you could survive here, you could survive anywhere. And so I'm going to continue asking that question. I'm going to continue looking to understand why. I think there are conditions that could create great entrepreneurs. And it's the first time I'm starting to see it. So I'm just very grateful to all of you guys to have this hard work and hustle continue to win, both in Silicon Valley, but also here in Argentina. And I'm grateful to be a bridge for Argentina into Silicon Valley. So thank you very much.